Hello, welcome back to the channel. So let's continue our discussion on differential equations, on separable differential equations, and let's solve these differential equations over here where we also have double derivatives in our differential equation. So the process about solving the differential equations where you have double derivatives is exactly the same process when you have single derivatives. The only difference is, since this is a double derivative equation, you'll have to integrate your equation or your both sides twice, right? Because it's a double derivative equation. Because taking the integral of a double derivative will give you a first derivative, and taking the integral of a first derivative will give you the original function, right? And similarly, in this case, you'll have two initial conditions because you're taking the integral twice. So you'll have two different constants of integration. Don't worry, we'll have a look at that, how this process will look like. But the main idea about solving these type of questions is to take the integral twice. So let's do that. So in order to solve for this question, we have been given that d square y by dx square equals 2 upon y cube dy by dx. So now we can proceed on to calculate the integral on both sides with respect to x, right? Because we know that if we calculate the integral of this side with respect to x, we'll get dy by dx. And if we integrate this side with respect to x, we'll get 2 by y cube dy in this case. Because if we take the integral of d square y by dx square with respect to x, and similarly on the right hand side, if we have 2 upon y cube dy by dx with respect to x again, on the left hand side we'll get dy by dx. On the right hand side we will have integral 2 upon y cube dy, right? So now this is an easy integral on the right hand side. It's basically 2y to the power minus 3 dy. So if we have to solve for this, it will be simply dy by dx equals 2 times y to the power minus 3 plus 1 upon minus 3 plus 1. And we'll also add the constant of integration over here. So our dy by dx will simply be equal to, this is 2 in the numerator and this is minus 2 in the denominator. So we'll get minus 1 by y square, because this is y to the power minus 2. And we'll also have the constant of integration over here, right? And now for solving this constant of integration over here, we have been given this initial condition over here. We have been given that when our y is equal to 1, our dy by dx equals 3. So if your y is equal to 1, your dy by dx is equal to 3 in this case, right? This is the condition which has been given to us already. So now we can substitute all these values. So it will be 3 equals minus 1 by 1 plus c. So your c will be equal to 4 in this case. So now if your c is equal to 4, your dy by dx differential equation will be simply plus 4 over here, right? So now this is your differential equation. This is your new differential equation, which is in terms of first derivative. And now you already know the methods to solve for this differential equation over here. You can simplify the right hand side, and your right hand side is basically 4y square minus 1 upon y square. So you can take the y square terms on the other side with the dy term, and on the right hand side you'll have dx. Now you can integrate both sides and solve for your y function in terms of x, right? Or you can calculate the opposite one as well. You can also calculate x in terms of y if you think that process would be easier for you to solve. So after we solve for this integral expression over here, we'll again have a constant of integration. And in order to get the value of that constant of integration, we'll use this condition over here. We know that when our x is equal to minus 1 by 16 log 3, our y is equal to 1. So we'll plug these x and y values into the equation to get our final answer. And if you'll calculate your final answer will be this expression over here. So in this case, it was easier for us to represent x in terms of y. So that is why you have this solution over here where your x function is a function in terms of y. So that's it for this video. Again, the main takeaway from this video is whenever you have differential equations where you have double derivatives, you'll have to integrate those expressions twice in order to get your original function at the end. And then in order to solve these equations, you'll have two initial conditions given, which will help you to solve for your two different constants of integrations. In the same way as we calculated our two constants of integration by using the initial conditions, the two initial conditions which we were given in this question. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.